Thanks very much for that. So let me get this straight. You guys have been like training for 15 weeks or something. And what are you training to do?
Volunteer.
Volunteer to do what? I mean, you're part of the Master Gardener program. Volunteer to be Master Gardeners, right? Yeah, yeah. And all y'all be? All y'all. That's my Texas just came out right there. Will all y'all be in Riverside area? Pretty much. Okay. Riverside County. So some of you are some of you from out in the desert? They already graduated. You sent them back to the desert before, just in time for it to get hot. That's nice of you.
We're a little down south.
So you guys are Western Riverside, and okay, good. So, this is going to be great. This is going to be good. I'm just going to launch right into this. I actually am going to talk about two different insect pests tonight. They told me I had 4 hours. Okay.
Then that last hour won't matter what he says.
Yeah, that's right. That's why she went to make that black coffee.
You can just talk about whatever you want.
Well, let's just go to this, all right? Because that might get far-reaching if I start doing that. What I'm going to do is talk about this. First of all, this one insect is called the pink hibiscus mealybug. Do y'all know mealybugs at all? Okay, good. So we don't have to go into too much biology about them. They're really weird insects. You know, their biology is really strange. This one is the pink hibiscus mealybug, and we call it that because all these mealybugs kind of have this mealy appearance, and that's what that is a waxy stuff that they exude off the backs of their abdomens, and that gets mixed with the phloem, the excrements of the phloem that they take out of the plant. The phloem, of course, is a very sugary, high carbohydrate substance in the plant. That's what carries all the nutrients and the sugars up and down the plant. And so they extract this from the plant, and then they excrete the stuff they don't need, and that gets mixed with all this waxy stuff, and it's called this mealy, waxy, sticky, nasty stuff. That's called mealy. So that's why we call this group of insects mealybugs. This one's called the pink hibiscus mealybug because it's pink, and it's hibiscus because it's on hibiscus. Entomologists are not creative when it comes to naming things. Interesting about this insect, though, it's not just on hibiscus. And that's where some of our problem comes in. In fact, this is what it looks like, that mealy mass that we have on there. A little bit about their biology. So the mealybug females, well, let's start up here with the egg stage. Let me see. Yeah. We start up here with the egg stage, and these are batches of eggs that the females lay. And there are 150 to 200 eggs in each one of these masses. They hatch after a little while into this first instar nymphal stage. And because they are really good at crawling around and finding other places to feed, they call them the crawlers. So that's the crawler stage. Then it goes through 4 different instars, of nymphal instars. Every instar, they get a little bit larger, and they start producing a little more of that wax off of the backs of their bodies. This is actually a 4th instar female, and this is an adult male. Now the females stay on the plant. They don't ever produce any wings. They use a pheromone to call the males, who then fly to them and mate them, and then the female lays these egg sacs, these ovis sacs we call them, and then the population all starts over again. So bizarre in one way, females don't have any wings. They really don't have, once they start to feed, they kind of just sit there. They don't really crawl around very much. So as I mentioned earlier, they feed on a lot of different plants. In fact, the last count that was published is 330 different plant species that this insect feeds on. Hibiscus being one of them, and when it feeds on hibiscus, it just obliterates it. These are the mealybugs feeding on the branches. They will essentially kill the plant. They'll withdraw so much of the wax out of there, and so much honeydew that gets on there, and sooty mold, which is this fungus that turns them black, it gets all over everything. So it's really bad. This is a mulberry tree that is another host for the pink hibiscus mealybug, and this is what it looks like at the base of the mulberry terminals. This is actually silk oak. Silk oak trees are used for landscape trees. All these are trees, these plants I'm showing are landscape trees out in the Coachella Valley. Silk oak trees are these beautiful trees that they have used on a lot of golf courses out there. And the mealybug gets into that, and it causes a lot of damage. And there's been a lot of tree mortality on the golf courses out in Palm Springs due to this mealybug. And then this is carob tree, which is another landscape tree that's used pretty prevalently out in the desert. And it gets on that and causes a lot of the same kinds of problems out there. I'm an agricultural entomologist, so I became aware of this because I work on dates out in the Coachella Valley. And as an agriculturist, there's three different really big ag crops that they grow out in the Coachella Valley. One is citrus. This is a host for the pink hibiscus mealybug. Grapes, and you grow a lot of table grapes out there, and this is the host. And then, of course, date palms, and they feed on the date fruit. So this pink hibiscus mealybug came into California actually originally back in 2008, down here on the north end of the Salton Sea. And it came in on a small grower planted a jujube crop. And I think there were about 5 acres that went in and had this mealybug that came with it. They basically eradicated it, got rid of it, and then we didn't have any more mealybug for a while until 2011. The ag commissioner started to pick up a few more mealybugs down in there. 2014, you see it's moving northward and westward, and it became all these sites here that are in red were actually nurseries, and on the nursery inspections that the ag commissioner was doing, they started to find this pink hibiscus mealybug on those nurseries. Well, that's when I became involved with it. As I said, I work on date palms. It's a fascinating crop. If you know anything about date palms, find out about it. And it's really a fascinating crop. I've been working on it for about 25 years now. And one of my packers, Hadley Date Garden, Albert Keck from Hadley Date Garden, he calls me and says, Tom, I've got these 30,000 pounds of dates. They came in these bins like this that came out of the middle of the city where they actually had farmed them. And he said, they got something on them, and I don't know what it is. So I went and looked, and this is what those dates look like. So these 30,000 pounds of dates were basically destroyed. Essentially, as I was saying a second ago, they came from these palm trees, and they use palm trees for a lot of landscape trees. I mean, you all probably know that. If you go down Disney Way, all those palms, those are all date palms. And there was an industry that got hatched out in the Coachella Valley of date farmers. When the price of dates went down, there was a fellow that figured out that you could real easily dig up the date palms and you can transport them. You probably have seen them on the freeways as you're going down the road, these great big semi-trucks with date palms on them. And so the date farmers were selling their date palms for landscape trees. Well, in the Coachella Valley, there were so many date orchards, date gardens originally, and when they went in and urbanized it, they left a lot of those trees for landscape trees. And so you'll see just rows and rows of the date palms. And these are not the Washingtonian palms. These are Washingtonian there. But these are date palms here. Well, some farmer or some fellow had decided in 2014 that he was going to farm these trees in the cities. So they went in and they did all of the practices that you need to harvest the dates. And because this was the area where we had that high mealybug infestation, the mealybugs just got into the date palms, and they ended up at Albert's, at Hadley Date Gardens Ranch. So I got involved with it. 2015, you can see it just kept moving into Palm Springs, and it's moving north, and a lot of the trees, a lot of landscape trees were dying. We lost every hibiscus plant that we know about in the Coachella Valley was killed by this mealybug. So it was really a serious problem. And so I started a project with my interest in mind and with the farmers' interest in mind of keeping it out of the ag area, right? Everything we've talked about so far is all up in the urban area. So let's keep it up there. We don't want to get it back in the agricultural area because then we've got this other problems about getting into our dates and our citrus and our grapes. So we started a project then. Let me give you a little bit of history about this insect, and this is going to be real quick. It's native of Southeast Asia. It's been a severe pest in a lot of different places throughout the world, so we know a lot about it. This is kind of what we do when we have a new insect problem that comes into California. By the way, we get a new pest in California every 60 days since 1956 when the records were being kept. Some of them stick. All of the pests that I work on and all the pests that you're going to see out there as master gardeners are all invasive species. Very few insects are native here. All right. If you think about California and the way that we move around, the people move around, and we move plant product up around the different states and different countries, really easy to see how we would get those infestations all the time. We have two borders. We have a port And we have 3 borders, 4 borders, other states. We have 2 international borders, and actually that's not true. We have 1 international border. You guys know what I'm talking about. We have a lot of borders. Anyway, there's lots of ways that these insects are coming in. Well, pink hibiscus mealybug is one of them. And what we do when we get one of these new infestations is we go to the literature, we find out where it's been known, and we find out what other people have done about it before we launch into our stuff. Well, pink hibiscus mealybug has been a pest for a long time in a lot of places. We found it was found in Hawaii in 1984, in the Caribbean in the 1990s. It's infested Florida. In every case, and this is very unusual, in every case we use biological control to control it. Yeah, it's like, wow, that doesn't happen in agriculture. This just doesn't happen. So, of course, I was interested in this process, and this is the biological control that we use. This is a parasitic wasp. These are stingless wasps. I always have to throw that in because every time we talk about wasps, everybody gets freaked out about we're releasing a whole bunch of wasps around. These are stingless wasps, And all they do is they seek out and lay their eggs inside the pink hibiscus mealybug. So then rather than the mealybug growing in there, it grows another parasitic wasp, which then emerges and goes to find other mealybugs. It's magic. And this particular species, Anagyrus kamali, is one that's been used since the early 1900s in all of these situations. So we thought, hey, bonus for us. Here's the wasp laying an egg. Actually, the ovipositor is inside laying an egg inside this second insar pink hibiscus mealybug. This is the way she comes out. This is a nice little hole through the mealybug. We call that a mummy, and that's the hole that the parasite comes out. And then she goes off to lay more eggs than other parasites and other mealybugs. Turns out it's not the first time we've had it in California. In 1999, it got into the Imperial Valley, down in the south end. And it was detected there. What we did, it was the same thing that we had in Coachella. It was on a lot of different landscape plants in the cities of Heber and Calexico and El Centro and Brawley. And at that time, CDFA, our California Department of Food and Ag, they instituted a biological control program. And I'm going to tell you a little bit about that. These are the 3 different parasitoids that they used. And I want to bring your attention to these. These are beautiful little wasps. Now, these wasps are about a 16th or a 32nd of an inch long. They're tiny, tiny, tiny guys. But if you get them up close and look at them, they're beautiful. The green eyes, nice coloration here on the side. These are grayish here. Another species down here. These 2 species in particular were brought into California. They were raised up and released down in the Imperial Valley. This is a very complicated graph, so I'm just going to break it down quick for you. And the most important parts are, this is where we started with our numbers of mealybugs. And these are average numbers that were counted on twigs, on terminals of different plants. And you can see they were very high back in 1999. After the first release of the parasitoids, our populations peaked here. And every year, they just got lower and lower. And then these are the numbers in these bars. These are the numbers of the parasitoids out there. So very effective. After 4 years, shut the program down. This is the coolest part. So the mealybug parasitoids did not kill all the mealybugs. They left a little bitty population that doesn't cause any damage. And why do they do that? So the parasitoids can stay around, right? So they just keep that population at a real nice equilibrium level. Never seen anything like that in agriculture. So it's beautiful. So we said, hey, let's do that, all right? So I want to go through, again, sort of what we do when these pest problems come in. I'm going to give you 5 objectives that we did and how we addressed this problem in the Coachella Valley, right? We've got this problem in the urban areas. We don't want it in the ag areas. We're going to do the best we can, and we're going to try to use this parasitoid to deal with the problem. Well, our first objective, and while we were doing this project, and there's a whole task force all up and down the state of growers and CDFA and USDA people that were on this task force, and we've been calling each other about every 5 weeks for the last 3 years. And so our first objective is that we learned that there was a facility down in Mexico that was rearing these natural enemies, these parasitoids, this Anagyrus kamali. And so we contacted them, and we formed a collaboration with them so that they would send some of their parasitoids up here, and then we would release them in our area. all right? This laboratory in Mexico raises 61 million of these parasitoids a year. So when we said, hey, could we get a few, thousand of them, they said, not a problem. You pay for the shipping, we'll give it to them for free. Amazing. Well, it turns out that this laboratory is just inland of Puerto Vallarta, down in Mexico. And because this was a new project, somebody had to go down to Puerto Vallarta to see how they did this process. And so I volunteered for the job and hopped on a plane and went down to Puerto Vallarta. And interestingly, I spent one night there. Yeah. Next time, my wife said, the next time you go, I'm going to go with you. I'm going to stay out here in this place. This is where I stayed. Anyway, this is the laboratory and some of the staff that were there. There were about 25 people working full-time to raise these parasitoids. And this is an interesting process, and I thought I'd share it with you. So they use pumpkins, these Japanese pumpkins, to raise the parasitoid. Or sorry, to raise the mealybug. You got to raise the mealybug to raise the parasites, right? So these are the pumpkins that they use. It's a particular type of pumpkin. They don't. This is Cucurbita mochata, which is one of the Japanese pumpkins. And after 3 weeks, this is what they look like after they put those crawlers. What we're doing in this picture is we're just taking a little sifter and we're sifting out those crawlers, and you can see the red on these pumpkins. Those are the crawlers of the mealybug. There's probably 2,500, 5,000 of the crawlers on each one of those pumpkins. After about 3 weeks, they turn into females like this and start laying a bunch of eggs. All right? Then they put them into a container like this, which is completely black. It turns out that these crawlers are attracted to the light. So they put them into these cabinets like this, and as soon as those crawlers start to hatch from the eggs, they close it all up, and those crawlers they've got some really very specific spotlights in here, and those crawlers will crawl to the light. And every day they come in and collect them. And these are like smaller than grains of sand that you're looking at there. There's probably 50,000 crawlers in these two little piles here. So they collect these every day. They collect these every day. And they can bring them in, sift them out. And I had them take this picture of me so I could prove that I actually did some work while I was in Puerto Vallarta. And here I'm salting the mealybug crawlers on there. And there they are. Isn't that cool? And then they grow up for 3 weeks. Now, they grow a lot of these, obviously. They're going to grow 61 million parasitoids. So half of them, they save to get the female mealybugs to get more crawlers. The other half of them, they put into what's called stinging cages. And stinging cages, it's a misnomer. These are basically oviposition cages. So at the right stage of the mealybug growth, which is only the second and third instars, and this is all timed out, as you can imagine, they will put them into a small cage like this, and then they put in about 2,000 parasitoid females in each one of these cages, let them grow up for about 3 weeks, and these are all the cages of all the parasitoids that are growing. All right? So they've got these come out. So every day they've got parasitoids coming off. Every day they've got mealybugs at the right stage going into the cages. It's all very well timed, and you can imagine it runs like clockwork, all under controlled temperatures and controlled humidity, so that everything works just fine. They take these after a certain amount of time. They have a process whereby they basically put some CO2 in and knock all the parasitoids out. They can dump them into a bucket like this, all right? And then they put them into containers that look like this. And each one of these containers has, they told us it was 2,000 parasitoids. It's actually about 1,400. I actually had my students count them. Only on 5 of them. I only counted on 5 of them. About 1,400 parasitoids. They ship them up here. We get them, and they're ready to go out of our quarantine. We have to bring it through our quarantine, make sure they're not bringing anything else. And then we're ready to go to the field. When they get here after 2.5 days of travel, they're really hungry. And one of the cool things that they do is that we feed them is honey. They like a high carbohydrate source. So we're able, let me go back to that. You can see in this picture, you see they're kind of lined up on these cards. These are some of my old business cards. It's a great thing to do with old business cards, is streak them with honey and then put them into the parasitoid cages. And you can see them here, a little more close up, see them all lined up here, lined up there and there. Well, they're actually just feeding on that honey. Then we take them out to the field, take the caps off of them, release them. They will search for about 1/4 of a mile, each one of them, and they're really, really good at finding the pink hibiscus mealybug. Isn't that beautiful? All right. So here, another recite. It's so beautiful. Yes, ma'am. These adults coming off of here, they're going to live about 10 days. Yeah. The whole life cycle from egg to adult, well, we'll see that in a minute, because I've got some temperature data showing that. Obviously, it changes by temperatures, but in these conditions, they're going to live for, a maximum of about 10 days, which is enough time for them to go distribute all their eggs, on all the mealybugs. So over a 2-year period, we released 247,000 of these parasitoids at 237 sites, all throughout the urban areas of the Coachella Valley. And at the time we were doing this, our thought process was the area that they're growing these at in Puerto Vallarta is very humid. The desert is not very humid. The desert's very dry and it's very hot. And so we weren't sure if these parasitoids that we could get for basically for nothing, if they were really going to work. So we thought we have a source of parasitoids in our own desert. Remember where they are? They're in Imperial, from the releases that they did back in 2004. So our second objective was to start a colony of our own from those parasitoids that are desert adapted. And so that's what we did. And this was really cool. So we had to have a source of mealybugs on some plants, and so we took some hibiscus plants. Now, we don't have this insect in western Riverside County. So everything we had to do had to be beyond the mountains. All right? So we got some hibiscus plants, no insecticides, because we're going to grow insects on them. And we took them to the Coachella Valley. We infested them with some of the mealybugs from down there. Okay, we got those mealybugs from some of our carob trees. Infested them. We had to grow them for a week to 10 days in the Coachella Valley. So we had to find somebody that would let us grow these hibiscus plants in their yard. Right, yeah, for a week to 10 days. And with all irrigation, and we had to wrap them up because one thing about these, with all this honeydew that they produce, the ants love them. So the ants would come in and graze on our mealybugs and graze on them and make a big mess. And so we had to cover them up, let them grow for 2 weeks, and here's our plants with all the mesh on them and the irrigation hose coming out the top. And the people, that's another story. Yeah. Anyway, it worked out pretty cool. Then we took them and we took these plants that are now infested with the pink hibiscus mealybug, took them down to Imperial County. And in the city of Calexico, we found some of these remnant populations that still had just a small amount of pink hibiscus mealybug and parasitoids. And we put these out in these people's yards. Okay? So we're seeding them for the parasitoids. And here they are. These are our trays down here. This is a carob tree that actually we found some of the very small amounts of the pink hibiscus mealybug. We're down in Imperial now. And those parasitoids came out of the trees and they parasitized the mealybugs on our plants. So after a week of exposure down there, we wrapped them back up, brought them back to quarantine at UC Riverside, brought them into the quarantine area, and we were able to rear out over 600 of the A. camali and 150 of the Duranosoidia indica females. And from those, we could start our own colonies, which is what we did. The third objective then is to establish our own insectary. Had to be in the Coachella Valley because we don't have the mealybug here. So we found a site on our field station down at CBARS, the Coachella Valley Agricultural Research Station. This is the site when we first started. We put in all the infrastructure to bring in trailers that we rented from Mobile Modular down here in Miraloma. They brought in the trailers. We hooked them all up. Had to have 3 trailers because we have one for the mealybug and one for each of the parasitoids. And you can't put them together because if the parasitoids get into the mealybug colony, they'll kill them before you're ready for them. So we have to keep them clean. Okay, I'll go on with that. So then these are our rearing facilities out in the valley. All right. We had to grow our own squash, of course, because we now have to grow the mealybug on something, and We ended up using a squash variety, a Japanese squash called black futsu. We became very good at growing squash. Now, we wanted to keep all the insects. So if you've planted a squash, any squash in Riverside, you know that aphids and whiteflies and squash bugs are going to kill you, right? Well, so we actually came in here and gave them a little dab of imidacloprid, which is Admire Pro. And each one of these little plants got a little shot of that. And here we are treating them with Admire to keep everything off of them. We planted them out in the field, and then we became pretty darn good squash growers. By the time that we were harvesting the fruit, that imidacloprid was gone. So then we could bring these into our quarantine and use them to grow our mealybugs. We became pretty good squash growers, as I said, and then we grew them up, just like they did in Mexico. See, I learned a lot in that one day that I was in Puerto Vallarta. And there's our squash with the mealybugs. And turns out that as we were doing this project, and we finally got underway with our rearing facilities down in the Coachella Valley, that we determined that the Mexico parasitoids really were working. And so this kind of took a second priority for us. And so overall, after, you saw we said 250,000 of the Mexico parasitoids, we actually ended up releasing about 2,300 of the same species of this one. However, with the Geranosoidea being a different species, we thought we'd get some layering of having more than one parasitoid in the system. So we released almost 15,000 of those at 81 sites up through the valley here. All in all, 264,000 parasitoids on almost 350 sites. So we pretty much have covered the valley. The last thing of this objective, and again, I wanted to go through this to kind of give you a feel for what we do in research. Now, the other thing is all stepwise. This I'm reporting on 3 years worth of work here with a lot of people involved. The last is, of course, to see are you having an impact on the mealybugs. Because we can release all the parasites in the world, but if they're not working, who cares? So what we did for that is we would take a 5-inch piece of the terminal. This is the terminal of the carob. This is the mulberry. We would bag them up, take them back to the laboratory in the Coachella Valley, because these have mealybugs on them. And then we'd count all those mealybugs on that little 5-inch terminal. Here are the data. Don't worry too much about these different crop plants, but these are the crop plants that we sampled. The blue bars represent the average number of mealybugs that we counted in 2015 when we started the project. So that's at the very beginning of the project. We had an average of 500 mealybugs on a 5-inch terminal. Okay? So some of them you can tell were really high. In 2016, 1 year after, we basically have no population down here. In 2017, we finally had a few plants that had just a few mealybugs, but this is an average of I think the average is about 7, which means that most of the plants were 0. One plant might have a few mealybugs. Remember what I said, this parasitoid leaves a few mealybugs around. So it's not surprising we find a few mealybugs in the area, right? And the other part of this that I'm not going to show the data is that the parasitoids they're widely distributed now throughout the Coachella Valley. So we basically have succeeded in shutting this down. So I took this picture on one of my drives out to the desert. It's a new day dawning. It's just beautiful and everything. And then 2014 fall harvest of the dates. These are the mealybugs on one of the bunches of dates. 2016. These are bags that they put over the dates to keep everything off of them, and you can see the mealybugs inside those bags. Last fall, we had some more mealybugs that showed up here. So we're not quite out of the woods yet. So I'm releasing parasitoids at all these places that they find these mealybugs. I was just down last week. I was up in the cherry picker, looking at the top of the trees, trying to see how are these things establishing, are they overwintering in the trees? I didn't find any sign of that. I think most of our infestation is coming. Well, let me just share that with you. Before I get there, though, we are doing some insecticide work because we want to have multiple tools. That's what we do in integrated pest management. Insecticides are part of integrated pest management, just like biological control and cultural control and mechanical control. Right now, we have no materials on dates that we can use on any plant-sucking insects. This being a plant-sucking insect, we're working on this material to see. And these are some of the materials we're working on. So far, they seem to be working pretty well. This is our mortality and our bioassays, and you can see that our Movento Savanto is giving us 100% control. These are 24-hour bioassays, and so That's pretty good. If we can get a material in there that we can rotate with these natural enemies or layer them with that, that's going to be good and helpful for us. Here's where I think the problem comes when it comes to the actual agricultural area. If you look real close, it's kind of hard to see. This is at the corner of Pomelo and I think Jefferson. And this is one of the big homeowners associations down there, and there's a ton of these when you drive down the Coachella Valley. All these date palms have bags on them. They're all being farmed. Okay? So there's some more. These are all being farmed. And so the chances of mealybugs getting into these is pretty high. You know, they're just still mealybugs in the area, even despite all the parasitoids that we're releasing. Now, some of them might have parasitoids, but if you get that date bunch and you put a bag around it, you get some mealybugs and the parasites can't get to them. So that's a problem for us. This is one of the issues that we have, and I'm telling the date packers down there, just be careful of this when you're getting these dates from coming inside the city. Okay? What happens is when the guys are actually using their equipment on these trees in the city, they take that equipment and they harvest their trees, and this is one of the cherry pickers that they use for harvesting, and they take it and they pull it out of the field and they take it right down to the heart of the date country and they harvest there at the same time. Well, they're bringing that mealybug with it. This is not a real good flyer. The males, they don't care about the males, they're not laying eggs. The females and the they're not flying either, they don't have any wings. The crawlers are catching rides on birds, they're catching rides on insects, and so this random insect that comes and lands on one of these infested trees then goes down to the date garden and lands in a bunch. Well, they're going to infest that bunch. And that's kind of the pattern that we see. We see a bunch here and a bunch there and a bunch there. Although last year I had somebody had a lot of bunches that were infested, but they're not. It's not like all the trees are infested. So far it's still at a pretty low level. But I'm worried that if we're not careful and you know, keep an eye on the issue that's going on, and people let me know what's happening down there, that we're going to have an infestation. The other problem that we have is that because of all these homeowners out there, every one of these people have a landscaper. The landscapers trim these trees, mealybug or not. In fact, if they're mealybug, they'll probably trim them harder. And they throw them into a trailer. Most of the landscapers live in the heart of the agricultural area. So they're trucking all this stuff back down there. They probably have a green waste dump right outside their house. They dump these mealybugs there. The birds are coming in, feeding on things. So that's bringing the mealybug to the heart of the ag area too. So we're just watching out for that and telling people to be careful. We feel pretty good about what's happened down in Coachella Valley. And we were pretty much ready to stop the program and move on to other things. And then CDFA put some traps out here on the west side of the mountains, in Riverside, up here in Reno Valley, Cherry Valley, out here in Beaumont, up here in Calamasa and Yucaipa. And we caught mealybug males. These are traps that have a female pheromone, so it attracts the males. And when you attract the males like that, it's an indication that you've got populations of the mealybug in the trees around it, right? We found 20 locations that had high numbers of males. This is the downtown Riverside, right here. You can see all these sites. So we're pulling up parasitoids from Mexico. We already shut down our trailers from here. We've turned all those back in because we know the Mexico parasitoids are going to work for us. So we've already released that there's actually 40. Yeah, there's 40 sites here, and we've already released at all of those sites. But this is where it gets important with you guys. The problem with this mealybug is that you don't see it until it's usually killing your hibiscus tree or it's up in the trees, or in the gardens. You see it in gardens. But as you guys are out there looking around, the more eyes we have, the better, intel that we have for this insect. So we have released so far 53,000 of these parasitoids out in the Riverside area. But this is important. Jot this down. Jot down my lab's phone number, even better, jot down my email. And if you take nothing else away from this presentation, Jot down my email, and when you see something that you think might be a pink hibiscus mealybug in this area, give me an email. Just say, hey, you gave a presentation at the Master Gardeners, and I'll come out and check it out. If it's not pink hibiscus mealybug, and there's a lot of different kinds of mealybugs, these parasitoids will not work. It is very host specific. So I can't just come and release it on, vine mealybug, or hibiscus has got 4 mealybug species that hit it. If it's one of those mealybugs, then I can't do anything about it. But if it's pink hibiscus, I can bring my parasitoids and we can release them. So I need your help, and this was really a good timing. They have a real assignment now, that could actually affect.
Right at the end of the course.
Well, that's the idea, right? You need another assignment to go out of here because you're going to be starving for things to do. I just know this group. And right now, CDFA, we're really concerned that this mealybug is going to continue to spread all through Southern California. So CDFA has just put in a new project with the USDA to monitor from San Diego, from the border, all the way up to Bakersfield, all the way up the Central Coast, up into Oxnard and Ventura and those areas. And so as they find more of these, going to be using these traps out there, and as they find more adult males, we're going to be releasing these mealybugs. But there's nothing as important as having your eyes out there looking for it. So really important project there that we're working on, and you can be a part of that. Questions?
I have one. When they put those traps in the trees, we get people like 2 or 3 times a year come through and put traps in our trees.
Yeah.
If they don't contact you, can you assume everything is okay? They haven't found anything bad?
Yeah.
And if they do, they will contact you.
Right, especially if they want to treat your citrus, they'll contact you. Which many of those traps are for Asian citrus psyllid, ACP.
Yeah.
And there's on,
apricot trees.
yeah,
Persimmons, and I think one in a walnut tree. They
Yeah.
put them all over your tree. Wow, what are you looking for?
yeah. So ACP is a big one now. So if you have citrus, and that's all the citrus greening disease, that's a bad turkey right there. That's a big one. Medfly, of course, there's still medfly, trapping medflies around the area, and releasing millions and millions of sterile medfly, sterile flies. I've seen some mosquito traps out there. Those are really cool traps. We've got a little fan down there that's with some dry ice, which is CO2, and the mosquitoes are attracted to the CO2, and they get sucked down into those things. And that's for West Nile virus monitoring. Prolificus shot hole borer is another one, and they're trapping for that all over the place now. So as these pests come in, we just need to have more and more information about that. So there should be something on the trap that says what it is and who to contact if you need to. Well, even better. Don't worry about it. Don't worry about it. If they're going to come cut your citrus tree down, they'll let you know that. Yeah.
If I wanted to grow date palms, where can I source ones that are not bringing into Western Recycling? Ones that are not going to be bringing in.
You don't need to worry about it. Yeah, you don't need to worry about bringing in the mealybug. They won't be. If you go to any nurseries out there that deal in date palms, and there's a lot of nurseries out there. I don't know. I've never tried to source them, but I'm sure you could Google that and find a source for them. You're not going to bring the mealybug over here. Besides of which, we already have it, and it's pretty easy to control.
There wasn't a dot in the label. So I want to make sure
Probably.
there's no dot.
Probably means that there weren't any mealybugs there. So these sites, they put out 2,500 traps in that area. I'm talking about kind of the eastern part of western Riverside County. Yeah. And these 40 sites were where they found them. So the sites where they didn't find them are not here. So they were trapping down in Nuevo, and so all the way down Hemet, Nuevo, that area was pretty well covered. But I appreciate that. You don't want to have a dot in your yard. Yeah, but go ahead and try to grow the date palms. That's cool. They need a lot of heat, and they need a lot of water, and they need a lot of care, and they're really spiny to work with. They're not a very fun crop to grow. You grow them in Calexico? Yeah. They say a date palm likes to have its head in heaven and its feet, its head in hell and its feet in heaven, because it likes a lot of water. In Coachella, a lot of the water table is really close to the surface, so they have it. There was a question in the back, yeah.
Yeah, I just wanted to thank you for educating me, because I have a couple hibiscus, pink one that gets aphids often, but I have another one that gets kind of a purplish flower, and last year it just got inundated with mealybugs, to the point the leaves turned black, the whole, everything got, I thought I was gonna lose it. So I use Dawn dish soap on a lot of my stuff, and I spray it with Dawn dish soap a couple of times, and, fall came, the leaves came off, I don't know, this year or whatever, I hope I didn't die, it's coming back.
Okay.
So, the leaves are growing, so I just wanna ask, knowing what happened last year, can it happen again this year? Do you think it could still be some?
Could be.
life in those?
Yeah. You need to use Joy. Joy works better than Dawn.
Does it?
Yeah.
Okay, so-
That's true. We use Joy dish soap in our, you know. It's a tough to know. It's tough to know whether they will survive. I've seen people cut them way back, you know, cut all the stuff off of them. And where do you live? Yeah. It's possible that some mealybugs, parasitoids from our releases will find them, because we're producing parasitoids now. But call me if they come back and call me. I'll come and check them out. Yeah. Yeah.
What would you recommend to clean or sanitize the equipment for the landscapers?
Good question.
Do they reuse the netting? Do they have to wash them?
So the date growers always are washing their bags. I mean, they clean their bags between season. It's one of the big costs that they incur with using these bags. So it's not the date industry themselves. The landscapers are probably going to, unless you did something from the Ag Commissioner's office where you mitigated something, they're going to continue to bring their stuff in to the valley. I think if we didn't have such a successful parasitoid, that we could petition the Ag Commissioner to do something about them not taking those materials down into the valley. The tools themselves, what I think happens is once one of these bunches gets some mealybugs in them, that the palmeros that actually work the date bunches could actually spread them from one bunch to the next bunch. This last year we saw one tree at 11 bunches, and then you'd have 15 trees with nothing on them, and then one more bunch, and then 2 bunches on this tree. So on that tree, I suspect that they're spreading them around with their, just being up in there, and they brush around those date bunches. It's,
There is the person
the palmeros, the guys that work the trees. Yeah, it's a very specially highly trained group of individuals. Lots of time passed down, you know, great-grandfather to grandfather and son, yeah. Yeah. I think-
Does that mealybug affect lantana?
Does this mealybug hit lantana? I don't know. I can find out.
I had half of my large hedge pretty much wiped out because of it. And I had to do a severe proof
On because it was mealybugs?
because of the mealybug. The branches were literally dying.
Yeah.
And had to cut it all back. And fortunately, it has recovered. No one would ever guess that I had this in the skeleton. Just 6 months.
Lantana's a tough bird. Yeah, especially if they're old plants. I don't know specifically, but if they come back, let me know. You also live in Riverside?
Yeah, in the La Sierra.
Yeah. Yeah, let me know. We can come release. Whiteflies love lantana. Whiteflies will kill lantana. Yeah. Yeah.
When they are found on citrus trees, do they change the fruit or they use the fruit at all?
Most of what we'll see on the fruit is, on the trees are going to be the foliage damage you have out there. But if it gets really heavy enough, then they feed more on the young fruit. They like the softer tissue. And if the population stays heavy all through the season, yeah, you could get some on the fruit. I think it would be pretty rare though to have them on the finished product fruit. There are a lot of other things in citrus. The citrus mealybug, for example, is a bad fruit pest. They really like grapefruit. When the grapefruit hangs together, These mealybugs like to be down into those two, those two fruit are hanging together. Citrus whitefly is another phloem feeder that causes a lot of honeydew. The red scale is another bad one that causes a lot of honeydew. So there are a lot of these sap-sucking insects that do feed directly on the fruit of citrus. I think the pink hibiscus mealybug is going to be more on the foliage, though. You have other questions about mealybugs?
No, but that was truly fascinating.
Got one more question there.
Do you know how you spray, like, you can spray anything like on roses, just water,
Yep.
spraying, anything?
It will. I'd put a little joy in it, though. And I'm not talking about smiling while you're, doing it. Yeah, there you go. Be joyful when you use the joy. Yeah, I mean, you can impact most of these insects if you want to do it 2 or 3 times a day. You can spray them all. Spider mites are the same, aphids, whiteflies, mealybugs. They're just going to come back straight away. If you wanted to have it least invasive insecticide solution, use imidacloprid, which is marketed under a product you can buy at Home Depot. It's called Bare Tree and Shrub, and it's magic. You mix it up, you pour it at the base of the plant. The plant will pick it up after several weeks. It picks it up into the roots, goes up into the plant, and it gets up into the phloem and the xylem. Guess where these guys are feeding? You don't affect any natural enemies, so your lady beetles and all your parasitoids are fine. But all those phloem feeding insects, and those aphids, whiteflies, mealybugs, it's not so great on thrips. Yeah, you get the point. And it's really a magic. You need to treat it probably every 3 months. Mix it up, pour it at the base of the plant. Just keeps everything nice and clean. And I do it. I treat my roses with that every year when I prune. Keeps the aphids off of the roses.
What if, chickens peck with their hearing toward that, would it affect the chickens? 'Cause I've got my citrus grove in my chicken yard. And the chickens keep it all nice and cleaned up underneath there, but they like it where it's wet.
I would have to. I would have to check and see what if there's any data on the oral toxicity. Oral toxicity of imidacloprid for humans or for mammals is low. That's why it's a nice material to use. I just don't know what it is, but you could probably find that out if you wanted to look at some of the labels of imidacloprid. IMID CLOPRID. IMID CLOPRID. Imidacloprid. 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 So how many of you know this bug? Bagrata bug. Well, if things keep going the same way it is, you might not run into this very much. But that wasn't the case back in 2009 and 10 back here. So I'm going to tell you about the current situation and what we did for this insect on crucifers. It's kind of a pretty insect if you look at it here, but it sure is devastating on coal crops. And it builds really large numbers, and this is what we had on our UCR farm garden in 2010. I went out there and saw these things that looked like little ladybird beetles. I thought, this is great, look at all these ladybugs, but they were not ladybugs, it was a bagrata bug. Again, just a little bit of the background of this is what we typically do. So the geographic origin is in Africa, Southern Africa, and the Middle East. All these other countries that we see here have pest problems with bagrata bug. I could add Chile to this list because they have bad problems with it right now. It is known as the painted bug. That's actually probably a better name than the bagrata bug. And some people call it the old world harlequin bug. Now these are all stink bugs, the true stink bugs. And this is actually, the insects in this particular group are true bugs. So when we say bugs, We talk about these guys as bugs. Even entomologists talk about them as bugs. All the other stuff that we talk about, like these mealybugs, they're not bugs. They're not true bugs. It's a systematic thing. Don't worry about it. It's all right. The reason it was called the harlequin bug is it does have some orange, and this is the harlequin bug. It has some orange and black patterns on it. This is the way that you see a lot of Magrata bug. They're in mating. This is the male down here, smaller the female here. And they'll run around like this for days. So a lot of times when you see them, they're in courtship behavior like this. So you might get them confused unless you had them side by side. And this is what the size of the harlequin bug versus the size of the Magrata bug. So harlequin bug is just, it's twice as large as the Magrata bug, so you wouldn't confuse them. It's kind of cool. Stink bugs themselves are kind of cool. Now we call them stink bugs because they actually have a gland on the back of their abdomen that produces a noxious odor, and that's part of their protection against predators. So if you pick up a stink bug in your garden and play with it, it's got a real pungent, kind of weird stink to it. It's not like manure stink. It's just this real weird, pungent stink to it. Fortunately, Magrata bug doesn't do this, but it's still in the same family as the stink bugs. Stink bugs are also cool in the way that they lay their eggs. So this is the harlequin bug eggs. Look how pretty those little eggs are. They lay them in these clusters like this. And so the female will sit down and she lays these clusters of eggs all at the same time. This is brown marmorated stink bug. Also, if you start reading any of the agricultural pest literature, you'll see a lot of brown marmorated stink bug. It's a very prolificous insect, lots of hosts, and it's spread all up and down the state too. Magrata bug's weird. It's different. It doesn't lay its eggs in these nice little clusters. If you get two of them side by side like this, it's unusual. But mostly they just kind of lay them on pieces of the branches, and sometimes they'll even lay them in the soil. And there's a video that this Scott Bundy, he's actually got it published out online, and the Magrata bug will come up, the female will actually just put her ovipositor in the soil, she kind of shakes her ovipositor like that and rubs it in like that, and she lays her egg there. And she moves on, she rubs her in like that. So it's just kind of interesting and weird. They'll lay them anywhere though. If you think about a parasite, and there are egg parasitoids. So there are parasitoids that will lay their eggs in the eggs of the stink bugs. If you think about a clutch of eggs, that's a pretty easy mark for a parasitoid. A parasitoid finds a clutch, they go boop, 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 boop. Nope, all their eggs are there, right? You start laying them in the soil, or if you start laying them randomly on leaves and stuff, it's a lot harder. The parasitoids have to search a lot more. And so they have to expend a lot more energy just to find a place to lay their eggs. So this is what we started with this thing. These are the stages of Magrata bug. This is the first instar, and this is the first instar on the edge of a penny. So they're pretty tiny. They're these really pretty reddish color as they get older, and these are insects on the face of a penny now. Fourth instar's got this really nice black and red coloration. This is a newly molted fifth instar, nice color, and then the adults have those other pretty colors on them. Let me get a shot of that. So those are immature stages. Well, we first detected it in June 2008 in California. And we found it at the port of Los Angeles. So we're pretty sure it came in with a shipment of something from somewhere. A lot of times these insects don't necessarily have to be on a host. They can be in a pile of lumber. It can be in chairs. It can be anywhere. Just have to hitch a ride and then they end up getting here. One reason that California is such a good recipient and why so many of them stick is we have the full range of environmental conditions here. We have the full range of host plants here. And so that's why it's so bad. Well, this is a timeline that goes from 2008 to 2015. Here's where it came into the port of Los Angeles. In the first year, it got into Riverside County, and that's where we started seeing it. It was like crazy in 2009. 2010, it's already out in the Arizona desert and the Coachella deserts, moving a little bit up into the Central Valley here. 2012, it starts moving out here, and we're starting to see it show up out here in Texas and New Mexico. 2014, continues to grow. We finally start seeing it moving up into northern coastal California. And it took till 2014 and 15 to get up into the coal crop areas. This insect, Magrata bugs, is a specialist on the brassicaceous plants. So the cold crops are your cauliflower and your broccoli, cabbage, and Brussels sprouts. That's the main crop plants in that. But there's a lot of mustard plants and a lot of those kinds of weed plants that are also in that particular family of Brassicaceae. But it took that long to get up into the Monterey County where they grow a lot of brassicas, and so we started scratching. I said, why the heck did it move so easy out to the east, but it took such a long time to go north here? So we started to address that, and this is what we saw when it hit here, just large numbers of this insect. And we had a lot of this stuff, right, every winter, except this last one because it had no rain. But we have these, and these are just, these are Brugada factories. So that's what happened to us, and these are the kinds of numbers that you would see on them. The crops that are at risk, I mentioned all of the head-forming brassicas, the cabbage, broccoli, cauliflower, Napa cabbage, all these sorts of things. Leafy brassicas, we grow a lot of those in California. Brussels sprouts are out there, some of these other plants, kohlrabi, and some of the Asian vegetables in the markets. These are some of the other plants at risk, radishes and turnips, and a lot of these ornamentals that are just grown everywhere. All right, rapeseed and canola, 1.5 million acres of canola grown in the central parts of the U.S. And then there's a few grasses and things. So, and then these are some other plants, tomato and pepper and potato and sunflower and blah, blah, so there's a lot of plants out there that this insect is going to utilize, even citrus, papaya, and artichoke. Now I say that these are plants that are utilized by Brugada. They're not particularly favored by Brugada. If these are grown in close proximity to other brassicaceous plants or a lot of those mustard weeds, you can get them moving into this and feeding on them. And so here's just some pictures of, this is a fig, this is cantaloupes here, this is a pepper, bell pepper, and I think this is actually a peach tree. They're feeding on the leaves of the peach tree. Okay, well, as I said, we were curious about why this distribution moved like it did. And so we started to do a little bit of research, and I want you to memorize this table. This is a very complex table. I'm going to narrow it down for you to one little bar here. What this shows is that we looked at the different responses and how fast the insect would grow at different temperatures, all the way from 20 degrees Celsius up to 39 degrees Celsius. And what we found is, like with most insects, as you increase the temperature, the time for them to develop gets shorter. Insects don't have an ability to control their own temperature. They are basically hostage to whatever the environment is. When it's cold, they stop growing. If it warms up, they grow faster. And so we proved that with Brugada, but the reason that we do studies like this, and you can imagine it takes a lot of work to set environmental chambers and get these kinds of data. The reason we do it is because then we can tell for real how fast they're going to grow at any particular temperature. And we can model that into this thing called a degree day. And a degree day takes into account how fast the physiology of the insect works, how fast it grows at different temperatures. Because if I tell you, I say, okay, we need to spray this insect when it's at the right stage, at the first instar. Well, how many days does it take to get to the first instar? Well, it takes 10 days. And you say, really? In the winter? No, it's going to take 50 days in the winter. How about in the summertime? Well, it's going to take 5 days. So you can't just say 10 days, right? But if we know how fast it develops, then we can model, depending on what the actual temperature is, we can actually grow the insect every time the temperature gets above a certain temperature. And we can grow that insect over time at different temperatures. When the temperature gets cooler, it grows slower. When it gets hotter, it grows faster. So we can model that and then start taking temperatures from different regions and saying it's going to grow that fast in that region. That make sense? Okay. You all understand that? Man, my classes don't even understand that. You all are doing pretty good. They're not master gardeners. Dun, 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 dun. That's right. You go, girl. All right, so this is the effect of temperature. The other thing I want to show you about temperature, and this is a whole bunch of other stuff too, but the pertinent points about this table that I want to show you is that if we take a look at the longevity, how long they live at the best temperature, this is the best growing temperature, which is 95 degrees, pretty warm. The best growing temperature is 95 degrees. It takes them, they will live for 33 days on average. They will lay 196 eggs on average at the best temperature. And it takes them for a generation 17 days. So it's pretty easy to figure out how we can have so many of these things under the right conditions, right? Not so bad. So if you take this degree day model and we accumulate those degree days, and we take a look at the central coast of California, and I ran the model from the 5th of September 2016 to the 4th of September 2017, just as an illustration. So 1 year, how many generations are they going to go through? In the central coast, they're going to go through 1.6. Here in Riverside, they're going to go through 5. In the desert where it's hot, they're going to go almost through 10 generations. So it helps us answer, no wonder they moved to the desert and built so fast. They were turning 10 generations over a year. They got a few of them up into the central coast, and it's cool up there. It's nice, moderate. That's why a lot of people like to live up there, right? But they also are not producing as many generations a year. So we kind of solved that problem about why they took so long. So our problem here in agriculture, 95 degrees is the best temperature. Broccoli is a cool season plant. You can't grow broccoli in the summertime. So it's a conundrum for us. We have a warm season pest on a cool season crop. And really, the time that it's worst, the critical time is when the seedlings are getting established. I'm going to show you this. This is really cool. So in the Coachella Valley, they typically go in late August when the soil temperature is about 120 degrees Fahrenheit. I mean, it's seriously hot. And that's when they sow the broccoli. They have to put sprinklers up just to keep the seed from cooking, and they sprinkle them up, and then the broccoli emerges, okay? I wouldn't have believed this if I hadn't done it myself and experienced it. We did a study where we actually put a drip tape in a field, and I wanted to make sure that we were very precise in where we planted broccoli seeds. So we put out a tape measure. I had all my team out there. Every 2 inches, we planted a broccoli seed. One seed. Every 2 inches for the whole field. Okay? After we planted that, we turned the water on. And 2 hours later, you probably can't see it here, there were clusters of Brigada bugs. Let me give a close-up of that. You see that? On top of every seed. Now, one thing we know about this bug, it's got a good sniffer. It can smell. Broccoli and cauliflower has that stuff called isothiocyanate that gives it that really cool, funky flavor. It's also a really interesting smell, right? And these Brigada bug are specialists on these. They can smell the seed. I wouldn't have believed 2 hours later, the seed coat had probably just barely started to imbibe the water. Certainly hadn't started to break coat, but there they were sitting right on top of those seeds. So we have this running joke, although I think it's true, these Brigada bugs sit there and just wait. And when that seed pops out of the ground, they nail it. And that's exactly what they did. That's the seed coat popping. Here they are. So these seeds come out of the ground. As soon as that cotyledon, as soon as the rachis just pops into the ground, the Brigada bug will feed on it, and they'll kill it. And this is what happened in the desert. This is a Brigada feeding on that. Those are cotyledons, and you can see that plant's basically dead. This is a healthy plant over here. This is one that Brigada's gotten to. All right, so what happens when they do that, of course, you have a whole ton of missing plants. And the farmer comes in and says, why are 90% of my plants gone? And they have to replant. By that time, it's late. And a lot of these vegetable crops, they operate very closely to schedule on time. As an example, when's the best time of the year to produce celery? When do you want to have your celery ready to go to market? Thanksgiving. If you're a week later, nobody cares about celery. Right? So these farmers, I mean, these guys, they are such amazing risk takers. Cantaloupes, watermelons, the earliest ones on the market. Second time is Christmas, of course, because it's a little bit celery. But that's just an indication. And so if he has to replant his field, that throws him back 2 weeks, 3 weeks. You might decide not even to plant. So this was a big problem. You get missing plants. If the plants survive, but the Brigada bug has fed on that meristematic tissue, that real young tissue, then it won't produce any fruit. It won't produce a head. And who wants a broccoli plant if you don't produce a head? There's nothing to eat. No florets out there. They call those blind plants out there. There's another blind plant. Just produces vegetatively. Or it produces these weird things. So you're basically messing with all of the hormones in the plant when you feed on the meristematic tissue. So you produce these things, and until we can start marketing these really small, weird heads, you know, well, multiple heads of cauliflower, again, they're fine, but they're real tiny. And who wants a real tiny head of cauliflower so the guys can market these Medusa stems on the cauliflower that comes out here? All right, so this was more of a straight agricultural problem. We didn't have the problems in the cities so much. We were out working on the farms. And one of the problems was, so we're planting this broccoli out here in August, and we plant all the way through April, all the way through the winter. But we're starting to harvest that then in March of the following year through May, and we want to know, okay, where are the bagrata bug going? Because you plant those seeds, and all of a sudden, boom, you got bagrata bug in there. There's no host that we know about, so we had to figure out where these bagrata are coming from. If you can figure out where they're coming from, maybe you can actually get rid of some of those alternate hosts out there. So we did a lot of studies out there, and we ran a whole bunch of these plants, these weed plants through, and we found out that, guess what? Black mustard, London rocket, shepherd's perch, sweet alyssum, vetch, brassicaceous plants, good hosts. We ran a whole bunch of crop plants out there in our area, and we found out that arugula, broccoli, cabbage, cauliflower, collards, corn was an interesting one for us. That's not a brassicaceous plant. Mustard, kale, Sudan grass, a lot of Sudan grass grown out in the valley, but they like those. And so we kind of completed that issue and started to tell farmers, okay, listen, pay attention to where you plant. If you've got Sudan grass right next to you, try to move your field or plant your first block furthest from the Sudan grass. At least have the bagrata bug try to make them work a little harder to get to your plants, right? Don't give them the salad right up front. Some other things that we do, as I mentioned, these bagrata bugs have really good sniffers, and so we wanted to have a tool. They're small, they're hard to sample. If you can trap them in, it's a good way to monitor for them. So we did a lot of work to try and figure out what attracts them. We find a lot of these bugs, they'll fly into traps or sticky cards. Sticky cards wouldn't work, they would hit it and walk right off. So they have to actually come in and they kind of bumble in and then they fall on the ground and then they walk to your trap. Okay, it's an interesting, crazy little bug. So we know that they aggregate because we've seen aggregations out there. A lot of insects actually have aggregation pheromones that both the males and the females produce, and it brings in both sexes for some of this mating orgy thing that goes on the plant. So we tried to find out what that was. We tried to see if there were sex pheromones that the males were producing, drawing the females in, or the females producing, drawing the males in. Didn't find anything. So what we essentially ended up with was taking alyssum and crushing it up and putting it into a bag, throwing that into our trap, and we could trap a lot of bagrata bugs. But there's our alyssum attractant, and let's say we could collect a lot of bugs in our traps, hundreds per day. We trap them at certain times of the year. Other times of the year, when we know that they were out there, we couldn't get them to come in. So it's like, well, damn, come on. So anyway, we kind of gave up on that and went to some other strategies for managing this thing. Bagrata bug is what we call a lacerate and flush feeder. And we talked about the mealybugs and the aphids. They feed in the phloem. They go with their stylets, go in, and they suck the phloem out. These are lacerate and flush feeders. These have a proboscis, but they basically go in and just lacerate the tissue, plant tissue. And bagrata bug is cool. If you have your two layers of your plants like this, your upper and lower epidermis, the bagrata bug stylets will go in, they'll feed here, and then they'll feed here, and then they feed back here, and then they feed here, and they create these really, really cool looking feeding lesions that are star-shaped. And it's characteristic. There are no other insects that feed like this. This is a sampling tool. So even though we can't attract them to a trap, we can go out there and we can look at foliage like this, and we can actually use that as our sampling methodology. And it's that way with whatever plants they're feeding on. They're really kind of these beautiful feeding lesions. So if you have this lesion in your vegetables, clearly it's bagrata bug. And sometimes the bugs, one thing that they do if you approach the plant, they fall off on the ground and crawl under the soil. So they don't like to be sampled, so they're really skittish. And so this is a nice mark that they leave us behind. What we actually found out is we can do a threshold based upon that. Don't worry about these data. Basically what it says is that if you have 5% of your plants that have feeding signs, it's time to treat. Well, that's kind of nice, because if you don't have 5% of your plants, and you can sample 100 plants, 5%, it's time to treat. If you don't have, don't worry about it. Sample them next week. And these are kinds of tools that we use all the time with sampling insects. Some of our management strategies, we do use insecticides, and the growers in the valley can put insecticides in their sprinklers, so the insecticides actually come in on the sprinkler. That works a little bit when the plants are really young, but they're really not very satisfying. We get 5 days of protection is all with our insecticides. Shanks applied, putting the insecticides, what seems like imidacloprid and clothianidin, putting them in the soil. That doesn't work at all, where they're really effective for whiteflies and aphids. So the plants aren't picking it up, they're not getting into the plant, to the Bagrata. Top banding, we get maybe 3 to 5 days of protection. So this is, it's a rough for us. This is just a table showing all the insecticides that got tested, and there's just, of all the insecticides that are usually used out there for these insects, there's just a few of them that give us 1 to 3 days knockdown. So it's just not very satisfying out there. There is a kind of a cool product called Nipsit. And you know that with broccoli seed, they're really small seed, and they will encapsulate it. And they'll put fungicides or insecticides around it. Well, in this particular product, they took clothianidin, which is one of these insecticides that gets up into the plant. And it turns out it works out pretty good. These are Nipsit seed back here. These are untreated seeds out here. We're going to run out of time, I'm afraid, so I'm going to move a little faster. You doing okay? Okay. Good. It's nice to see you. Cultural control then, if you can avoid it, like I was saying earlier, you want to do that. Weed control, of course. We know some of the weeds and other plant control. Try to do that. This is a typical field down in the Coachella Valley with brassicaceous weeds growing right on the edge of the plant. Tell farmers to try and reduce that kind of stuff. Transplants, of course. What we have found out is that if you do a transplant, now planting by seed is really cheap. If you have to plant a transplant, it's I don't know how many times, but it's a lot more expensive. So seeds might be pennies per plant. Transplants might be dollars per plant. So it costs growers a lot to use transplants. However, it has turned out that if you do a transplant and that plant has at least six leaves on it, that the Bagrata bug won't cause the damage. So we did a lot of work on that. These are the data that shows if you plant a plant that has only cotyledons, you're still going to get about 60% damage. If you plant a transplant that's got 6 leaves, then it's down here with about 10% damage. So based on this experiment, and this was a long-term experiment, but based on this study, farmers in the valley started to use transplants exclusively. So they quit using direct seed for a while. Biological control is something that we're working on in my lab right now. We're working with some overseas collaborators, and entomologists have colleagues all over the world. There are a couple of laboratories, one in France, one in Pakistan, and one in South Africa. And with these colleagues, they go out and collect for us. And collecting in Pakistan, which is one of the places of origin of the Bagrata bug, they sent over 3 parasitoid species to our quarantine. One is Trisochus hyalopinus, the ground species, and Oencertus near Telemedicida. We actually have this one in our lab that we're working with right now, and this is one of our rearing cages. And you remember I told you about that honey feeding? This is a streak of honey here. This is so cool. These are the eggs that we have that we give them. This is the little Bagrata bugs feeding on a little strip of honey here. That's really cool. And they're very beautiful, small little parasitoids as well. What we're doing with these is we're looking at their oviposition biology, how fast, what temperature we should be raising them at, and then will they hit other insects, other stink bugs. Remember, this one came from Pakistan. Until we get clearance and know all about it, we can't release it out in the field because it might start feeding on some nice stink bug, whatever that would be. But you know that there's a lot of a lot of stories about there about releasing parasitoids that become devastating to natural natural insect populations. We can't do that. So we're going through all this work now to try and see if this is going to be a candidate for release for us. Organic farming is really important, especially up in the Central Valley, and it's becoming more important all through California for broccoli and cauliflower. And there are a couple of things. One of these parasitoids that we're working on. There are some fungi that are, we call them entomopathogenic. These are fungi that feed on insects themselves. And there's a couple of these species that are known in different strains that were collected from specific insects that become specific for strains. And so these are some of the Bagrata bugs that have been inoculated with these particular fungi. And just like fungus grows everywhere, the mycelia grows inside the insect and the sporulates on the outside. And then those spores can spread around and get onto other insects. So this is one of the ideas we're working on. One thing about fungi, that's one of the downsides, is they require high humidity. Well, where are we doing this work? Out in the desert. You know, so unless we can modulate the environment by irrigation, which we can do some of that, the fungi are going to have some limited geographic uses. We use our pyramid traps. This is one of the coolest things out here, that for organic Bagrata bug control, people can use vacuum that actually suck the insects off the field. There are now machines that mount on tractors. This was actually a shot I took up in Oxnard of an organic strawberry field. And they drive this machine through there, these monster vacuums, and it just sucks the insects, whatever, and it blows them out these vacuums and shreds them as it shoots them out the top. They run this through the field, not inexpensive, because of the tractor moving through there. It doesn't leave a small carbon footprint, but it does suck the bugs off of there. They were using this actually for lygus bug, which is another bad insect that feeds on the strawberry fruit. Isn't that crazy? Row covers are something they can use, again, very costly, but they simply essentially cover the plants, and you can put those flat against the plants and the plants will grow up underneath them. Got to make sure, we did find out that if the broccoli plants were rubbing up against the mesh, that the Bagrata bug were still feeding down through the mesh. Little suckers. All right. And then timing of our transplants, and using transplants, of course, and then timing of our planting. So maybe you can avoid when the Bagrata bug are out there. So these are some of the organic things and some of the other types of pest management strategies that we use. So once again, we've got biological control we're using with both parasitoids and the fungi. We've got pesticide control that's out there that growers can use. We've got all these other kinds of strategies that we use. And the true meaning of integrated pest management is taking everything that you can apply and putting them out there. And if it's cost effective, then those are the strategies that farmers want to use. And there's some biopesticides that are out there, some of the soaps and things we were talking about. I don't see Liquid Joy up there. These are actually products that you can buy out there. So Impede is a soap product, and there's some other things out there that are natural byproducts. So this project has been going on for a long, long time in our lab with a lot of people from across the country. These folks from Mississippi and New Mexico and Oklahoma State, who's now in Tennessee, and all these folks here in my lab and in my team, and then my current group here. And so lots of funding, lots of research has gone into this. One of the coolest things, though, this is kind of the postlude to this story. We're able to collect these Bagrata bug eggs. I have cages of Bagrata that would fill this room. That's no kidding. These bug dorms that are, about this big, and we would have enough to cover this whole room of Bagrata bugs. So we grow a lot of Bagrata bugs. Got to keep our plants clean, and we give them all these little brassica plants. So we can collect these eggs. We take these eggs and we get an index card and we put glue on it, stick these eggs on the card, and we can take that card and put it on a landscape flag out in the field. And why do we do that? To get parasitoids to hit those eggs. Okay? Bring them in the lab, put them into a little petri dish, and we can pull off eggs. We found out since last November there are 4 species of parasitoids from other stink bugs that are hitting our Bagrata bugs. And what we've noticed in the last 3 years, we can't hardly find a bagrata bug. Now you get this research project going, you got all these students, everybody's all, and then the problem goes away. That's very typical with entomologists. But we couldn't figure out what was going on. Okay, well it didn't rain, so we don't have the overwinter hosts. Yeah, but even on the hosts that did come up, riparians, we didn't find any. We have 4 species. And the other really cool part about that, one of those species happens to be a species that's only known from Pakistan. We didn't release it. It probably came over on the same boat with bagrata bug, 2008, 9, 10, whenever. And now it is established. We're working with a citizen science group out of the LA Museum, and they've got some traps that they put around and collecting all kinds of insects. And they've recovered 4 of these parasitoids that we have in quarantine. It's not supposed to be here, but they're finding it in the field already. Projects is that you just never know till you start putting your eggs out there. That was a bad joke. That was a really bad joke. You never know what you might find, right, or what's going to happen. Anyway, I'll be happy to answer any questions. You guys have been such a fun crowd to hang out with. So, some questions, yeah.
Are there other bugs out like that where in the black markings? The last couple of years on the butterfly weed, it's black and orange flag, but anyway, and they're like clustered on it, so they're like eating plants.
So there's an insect called a box elder bug that are on trees and stuff, and they end up all coming out at the same time. Check that one, box elder bug. It's a larger bug. Bagrata bugs, they're like little lady beetles, and it's very possible that you had some congregations of bagrata bug.
What is this one? That's on my milkweed.
Those are nymphs of. You're going to love this. Milkweed bugs. Yeah, that's the box elder bug. Those are nymphs. Those are immatures of milkweed bugs. Yeah. So. Well. But it's not. It's a bagrata. Take a picture and email it to me. And you all can do that anytime. Yeah. Class, now class. Now class.
I left my yard all full of weeds, and I went out there since the
I'm sorry. I was explaining your timeline. You're right, busted. I'm sorry.
She's got a really important question.
No, I was digging all these weeds, and I was thinking to myself, wow, this is really weird, all these ladybugs. But it wasn't, it was these things, because it was a lot of the mustard, and I'm physically digging them out, and I was feeling bad about removing
Killing the
all those.
ladybugs.
Yeah, no, not killing them, but removing where they were living. And now that I saw it, and you said it looked like ladybugs, I realized that's what it was.
Yep.
all these weeds.
Was that recent?
Yeah, that was about 2 weeks and 3 weeks ago.
Really?
Yeah, but I mean, I had a really good backyard. I physically dug each one of them out.
You live in Riverside? Oh, they're all gone?
About,
Oh, they're all gone? Oh, your weeds all gone? Your weeds are all gone?
the weeds are all gone. I physically dug each weed out and trapped.
We could have come over and got some for our colonies. Yeah, they were bagrata bug, and they will overwinter really down in the crown of the plant. They like to get under any duff and stuff. Duff and stuff. Under the duff and
And that's why I saw
yeah,
it, because I was
yeah,
taking the weed out,
yeah. Ladybugs do that though. Y'all know the story about ladybugs, right? Did you see that on the internet? The first time I saw something on the internet was actually true. Well, you can go down to, this is really a sidebar. You can go down to Lowe's or Parkview Nursery and buy lady beetles, right? And they come in these little containers, and it costs $10 or $12, whatever it is. And you know where they come from? They go and collect them up in the mountains, because ladybugs always fly to the mountains, and they congregate for the winter. And they are piles and piles of these ladybugs just piled up. And these companies go up there and they scoop them up, stick them in there, sell them to you for $10. And you know the first thing ladybugs want to do? Go back to the mountains.
When I lived in Michigan.
It's a true
they
story.
used to
That's
get
true.
in the windows.
Yeah, that's a different, that's the
Is it?
Asian ladybird beetle, yeah.
But
That
you
was,
do that in the winter. And
that was one of the big faux pas from the United States Department of Agriculture. They brought that lady beetle into the United States to feed on aphids that were, I don't remember the aphid species, a soybean aphid or something like that. And they didn't do their homework and realized that these insects like to congregate in really tight places, like under the eaves of people's houses and in their windowsills. And if you go back to the eastern part of the U.S. from Chicago east, these things in the wintertime just are massive in your houses.
that's what I've never seen that.
So that,
before.
USDA changed their rules after that, as they should, and so some of the stuff we do is under the rules of that
I
country.
was explaining to her your timeline of those bugs, and as soon as I saw them, it's like, I wonder if alyssum's on that list, because my neighbor lady, she says, "Stu, come over and look at these, and she lifts up this alyssum and hundreds of these things.
Yep.
And everywhere, and she has a whole frickin' yard of this stuff. And they're everywhere, so then I go home to my yard and lift up the alyssum, and my God, there's thousands of them there too. So we don't have any more alyssum in my yard, but she does.
This is also recently?
No, that was about 5 years ago.
Yeah.
And once we got rid of the alyssum, because I finally talked her into getting rid of it, we have not seen them in near the congregation they were.
Do you like alyssum?
No, I know.
You don't like, well, tell her to replant. 'Cause these parasitoids are working now.
Oh, yeah. Oh, there you go.
Yeah. I mean, really, we can't find them. We can go on
We
into,
haven't seen any for
very
probably
few.
4 years.
yeah, that's about the right time frame.
Wow, that was amazing.
But in 2010, boy, they were everywhere.
Yes, it was
Everywhere.
incredible. I'd never seen anything like it,
Yeah.
except the ladybugs.
So I'm propagating a listen, right? I'm curious of it. If you find some bugs, we call you?
You can. If you find pink hibiscus mealybug, that's more important. Yeah, I mean, if you have a whole ton of them or something, yeah. We collect a few every spring and, you know, put them into our colonies to kind of help do that. But we're doing a lot of research. We're using probably 200 Brugada bugs a day, Brugada bug eggs per day. So we have these colonies that we're constantly. So if you have some, we could, if you're close, we'll come pick them up.
But why are you still working with me if you have these parasitoids to take care of them? What are you still looking for?
Because I have a grant
Bottom line,
that I have to have some results for.
I got.
No, that's not untrue, but
Results would you turn in if you recognize these parasitoids, then what kind of results are left?
yeah, that is not untrue. We do have a grant that we're working on.
Yeah.
We're working on one of these parasitoids, not the one that we've collected here actually, but a different one that came. We have found out that it's a pretty good generalist, but we want to find out more about the biology of it. It doesn't exist here, and depending on what the biology is and how it could fit into the system, it might provide another release organism for Brugada bug. You know, I mean, if every project that I did, we stopped doing it when the insect or the mite became less of a problem, I wouldn't have finished anything. So there's some good biology to be gained here. I've got a graduate student, who's a PhD student, who's working on this. It's her project, and so we'll finish it up. Yeah, that's part of the. Well, I got to do it. So. Well, again, you guys have been a great audience. It's been fun to be with you. So good luck with you out there, and call me.